Hello and welcome back to the Cracking FAANG YouTube channel. Today we're doing a highly requested problem, 1233, remove subfolders from the file system. Given a list of folders, folder, return the folders after removing all subfolders in those folders. Wow, how many times can you say folder? You may return the answer in any order. If a folder of I is located within another folder of J, it is called a subfolder of it. A subfolder, folder J, must start with folder J followed by a slash. For example, /A/B is a subfolder of /A, but /B is not a subfolder of /A/B/C. The format of the path is one or more concatenated strings of the form / followed by one or more English lowercase letters. For example, /Leetcode and /Leetcode problems are valid paths, while an empty string / are not. So let's look at an example here. So we have folder, and we're given that /A/AB /CD /CDE and /CF. So the answer is /A/CD/CF. Why is that? Well, we can see that /A is on its own. It can't really be a subfolder of anything else. So that's why this one is considered a subfolder. So when we get to /A/B, obviously, this is a subfolder of /A, therefore this one we can get rid of, right? Because /B is a subfolder of /A. So when we get to /C/D, we actually don't have a folder called /C. We just have /C/D. Because we don't have /C on its own, this one is actually not a subfolder, even though it has kind of a subdirectory within it. So that's why this one is considered not to be removed. So this is kind of considered unique here, right? And then we have /C/D/E. So basically this prefix is already here. That's why this one is actually considered a subfolder, and we end up getting rid of it. And then /C/F. This is also considered a subfolder because, again, we don't have /C on its own. Therefore, /C/F cannot be a subfolder because we don't have /C. So this one is considered its own kind of folder. A bit strange, but that is kind of the problem here. So as you can see, we have strings and we have a prefix, and this actually lends itself perfectly to a trie problem. So let's kind of just wipe away this text and see how we might implement this. So basically, we can build a trie. And obviously, this will be the root of the trie, which will have nothing. And then at each kind of level, we'll have the first prefix string that we have here. So this will be /A. And then we can basically say, okay, what else do we have? We have, /AB. And then we have, so because this is kind of on its own, one of the great things about tries is we actually know we can store on each node not only the value, but we can tell whether or not it's the end point. So for example, A is a terminal node, and also AB is. So basically, if we have a node and we have, it's the child of something else and it's a terminal node, then that means that we can get rid of it because we have a parent as a terminal node. So for example, if we have something like, where's my pen? So if we have for CD, right, this would be the prefix C and then /D. And the reason that even though /D is technically the terminal node here, because /C is not a terminal node, we don't get rid of it. So we only get rid of it when a given node in the trie is a terminal node, and actually its parent is a terminal node as well, which signifies that it's a subfolder. So in this case, since /C is not a terminal node, we don't get rid of it. But for example, when we do CDE, right, so from D we go to /E. E is obviously the last item here, so it's the terminal node. And because its parent is a terminal node, that means that this one is actually a subfolder. Same with kind of CF, because we have /F here. Even though F is a terminal node, because its parent is not, then that means that this entire path actually is it's not a subfolder. If /C was, then this would be a subfolder, and also with this D. But because /C isn't a subfolder, then basically we don't consider that to be a subfolder, and that's why we don't get rid of those in the final output. So that's basically the algorithm we want to do. We just want to build our trie here, pretty straightforward. Just store the value of the node in the trie, so whatever the character it is, and then we'll store whether or not it's the terminal node, as you would with any other trie. Then we just need to traverse it, go through the trie, and then basically just split out each piece here, traverse the trie as far as we can until we get to the terminal node, and basically just figure out whether or not, okay, we've hit the end. Was its parent a terminal node? If yes, then that means that this path was actually a subfolder. If not, then we can basically just say that it's not and add it to our solution. So a little bit convoluted, especially because tries, you have to build your own. There's no data structure for it in Python, but that's generally the algorithm. Just build the trie, traverse it, and it's pretty straightforward. So let's actually go and now code this up. Okay, let's now code this up. Remember that we actually need to define our tree node class. So let's quickly do that. So we're going to say class, trie node, and this is going to take, let's see, we just need to init, and it does what? So we store whether or not this is the last node. So we just do self is end, and we also want to store the children of this node. So there we go. So we're going to say self.children. This is just an empty dictionary. So now what we want to do is we actually want to populate the trie. So we're going to say self.trie is going to equal to a new trie node, right? So just empty in the beginning, and then the children will populate them as we go along. Now what we need to do is actually go through our kind of folders here and actually populate them. So we're going to say for path in folder, we're going to say that the current root, or I guess we'll just do current node to not confuse ourselves. So the current node is just going to equal to the root of the trie. And then the folders in this path is going to be folders equals to path.split. And we're going to split on a /. Now we need to go through all of the folders and basically populate the trie, right? So we're going to say for folder name in folders, we're going to say if we actually split here and got somehow an empty string, we just want to ignore that and continue in the case that somehow our path is malformed. So we're going to say if folder name equals to an empty string, empty string, then we can simply continue. Otherwise, we need to basically populate the trie. And we also only want to put this folder name in it if it's not already in the children of whatever the current node is. We don't need to duplicate it, so there's no reason to put it twice. So we're going to say if folder name not in cur node.children, then we want to populate it. So we're going to say cur node.children of the folder name is going to equal trie node. Okay. Cool, so that is basically that part. And then obviously we need to move the kind of trie one level forward. So we're going to say the new current node is going to equal to current node dot children of whatever folder name we just created. Okay, cool. And then once we get to the end of a given folder, the last thing we need to do is whatever the current root is, we need to mark that as the end. So we're going to say current node dot is end is going to equal to true. Cool. So now we have successfully populated our trie. What we need to do now is actually traverse it and basically find our answer. So we're going to need a result here to store our solution. And now we can actually process the trie. So again, we want to basically go through the path in our folders, parse out the variables, I guess the path names, and then do something with them to determine whether or not it's a subfolder. So let's basically just reuse the code we wrote. So for path in folder, we're going to say that again, the current node is just going to be the root. So every time we start at the root of the trie, I think we called it self.trie, not root. Yeah, so self.trie. And again, we need to split. So we're going to say folders equals to the path.split on /. And then we need to basically keep track whether or not we have a subfolder. So we're going to say is subfolder equals false. Now what we can do is we want to basically iterate through our folders. So we're going to say for I folder name in enumerate folders. Again, if the folder name is an empty string, then we just continue on to the next one. We don't do anything. So we're going to say if folder name equals to an empty string, then we just want to continue. Otherwise, we want to basically, now that we have a folder, we want to get its child, because remember, we want to check if the child is the end node, then that can potentially mean that it's a subfolder. So we're going to say if, so we get the next node. So the next node is going to equal to the current node dot, so get out of the children, whatever the folder name is. So now if the next node, if next node is the end, and remember that when we had a structure where if the parent was the end node and the child was an end node, then anything below it basically was a subfolder, right? So if the next node ends, and we need to check whether I does not equal to the length of the folder in the current path that we're working with. If it's not the last one, then that means that somewhere below there will be kind of another end, and therefore kind of we have just found a subfolder. So basically, if the current node, the next node is an ending node, and we still have more to process in our folder, then that means that we basically found our endpoint, right? So for example, when we had something like /a, if we're processing /a/b, and we notice that, okay, we're processing a, and the next one is or we have something like a, b, c. If we're processing b, and we see that, let's see, how do I explain this? Let's see. Okay, sorry, I had to take a break there to basically just figure out how do I explain this. So for example, if we have the path /a in our trie, and we know that this is kind of an endpoint, and then we're processing /a/b/c, when we process this, obviously we start at the root of the trie, and we're going to check, okay, what's the next item here? So it's a, and we're, right, next node will be pointing to a when we start from the root, right? So we're going to check, is a an endpoint? Which it is, because we've, a previous folder was /a. So if a is an endpoint and we still have something else to process, then that means that this entire thing is a subfolder, right? Because obviously ABC is a subfolder of /a. So ABC is its own folder. So /a is a subfolder, and then obviously we have more stuff in it. So that means everything else to the left of it is actually, extraneous, right? So we can get rid of this. So basically, in this case, we want to just mark that it's a subfolder. So we're going to say is subfolder equals true, and then we can actually break out of our for loop because we don't need to process this folder anymore. So once we kind of get out of this, the last thing we need to do is we're going to say if not is subfolder. So basically, if it's not a subfolder, then we want to add it to the results because we only care about the non-subfolders. So we're going to say result.append the current path. And then, yeah, I think that's basically all we need to do. This will basically find all of the paths that we want, and then we just need to return our result. Let me just make sure I didn't get anything wrong. D. Let's see. Folder name. Did I not populate the tree node? Okay, 1 second. Found the mistake. And actually, we forgot to update what our current node is. So we're going to say the current node was the next node, right? So we just need to update that, and now it should work. Cool. There we go. Fucking hell. And all right, cool. We are accepted. So, God, this problem was absolutely horrible. Let's just do the time and space complexity and get the hell out of here. So, time complexity, obviously we need to parse all of the folders. So that's going to be big O of n. And within each folder, we need to go through character by character. So we're going to say this is big O of n times L, where n equals num folders and L equals to the length of the longest folder path, I guess. So basically that's the thing. For each folder, we need to basically parse it out, and however much parsing we do depends on the length of the path. So for the space complexity, I believe it should just be, in the worst case, they would all be unique paths. So it would just be kind of dependent on, I guess, the sum of L, I guess the sum of all the lengths, right? Because all the paths would be unique. That's how many nodes we'd have. I don't know, maybe we can just call this O of, I don't know, little l, where L equals to num distinct, I guess, folders in the paths. So that's how you solve this question. I really did not enjoy this. This was a massive pain in the ass. I generally don't like try questions, but some people requested them, so hopefully my suffering was worth it and my explanation made sense on basically how we solve it. And we check whether or not it's a subfolder or not. So yeah, hopefully you enjoyed it. If not, sorry, I hate these questions. I don't usually do try questions, but whatever, I felt generous today. So hopefully that makes sense. Anyway, if you enjoyed it, why not leave a like and a comment? Helps out with the YouTube algorithm. Subscribe for more content like this. I promise most of my videos are much better than this. And I will see you in the next one. Bye.